Welcome all. Today we will have a brief lecture on layouts and stick diagrams. So first we will see what is called as gate layouts. It is working under the principle of line of diffusion rule. So under this it has 4 layers. The first layer is metal ground at the bottom. So this is the first layer. The second layer is this layer, which is called N diffusion. The third layer is P diffusion, and fourth layer is metal power at the top. So these are the 4 horizontal strips which has been used to draw gate layout, and this gate layout is meant for drawing a compact way of representing things. So if you take a normal inverter, the first is PMOS. PMOS source is connected to VDD. Drain of the PMOS is connected to drain of the NMOS, and source has been connected to ground, and these 2 lines have been joined, and this is nothing but A and this is nothing but Y. So this area is called N well. And what is CMOS? CMOS will contain PMOS plus NMOS. So there will be a common substrate where the substrate will be P type. So in the P type we are able to construct N type of MOSFET. If you want P MOSFET, then we have to go for N well. Inside N well you can put this diffusion, which is called P diffusion, to construct what is called as PMOS transistor. So this is going to represent PMOS transistor, and this is going to represent NMOS transistor. Both gates have been joined here. So both the gates have been joined. So this material is called polysilicon. So this is going to be my input, which is A, and this drain of the NMOS and drain of the PMOS, they will be connected, and this connection is called metal connection. So which will be the place where you are going to take the output. So Y is the output. So this is the way you should understand that. So in the power line as well as ground line are often called as supply rails. The polysilicon line will run vertically to form transistor gate. So this is my polysilicon, which is drawn vertically, and metal wires with cell connect the transistor appropriately. So we want this drain of PMOS as well as drain of NMOS should be connected through this metal. So this is the way to understand. So it will contain 4 diffusion layers. 4 layers. First layer is metal ground, second layer is metal power, third is N diffusion for constructing NMOS, and P diffusion for PMOS. Next we will understand what is called as stick diagram. So stick diagram, it is a step before going into the layout. So a stick diagram is a cartoon of a layout. And why you need this? So we need this to plan layout very quickly. That is the reason we are going for drawing stick diagram. It doesn't have any scale. So you have to maintain some colors for easily understanding what you are representing in layout. Suppose if you want to make N type of MOSFET, then you should go for N diffusion. If you want P MOSFET, then go for P diffusion. And poly, it is nothing but the gate material. So if you want gate, then you go for poly. And metal, in the previous slide we have seen that on the top of every gate layout you will have VDD. So this is the top layer, and bottom layer is nothing but the ground. So always N network will be connected towards the ground, and P network will be connected towards VDD. This is the convention which has been followed. We have some rules. When two or more sticks of same type cross or touch each other, that represent electrical contact. So both these lines are nothing but the metal. Blue lines are representing metal and red lines are representing what is called as polysilicon. So when they are crossing one over the other, it says it is having electrical contact. That is the first rule. Second rule, when two or more stick of different type cross or touch each other, there is no electrical contact. So this is my metal, and this red is nothing but polysilicon. So they are crossing one over, so it doesn't say there is no electrical, it says that there is no electrical contact. Suppose you want to explicitly say that this has been connected, then there should be this dot represent there is a connection between two layers. So if electrical contact is needed, we have to show the connection explicitly. So this is the way to represent there is a connection. So here it has been, this point has been connected. When you take this, both are crossing one another, but no electrical contact. And rule 3, when a poly crosses diffusion, it represents a transistor. So we will take up, we'll understand this. So N diffusion, green line. So and P diffusion, yellow line. So we will go here, we will take up green. So this is my green, so this is my N diffusion. And if you go for poly here, so this is going to act as my gate. This end it could be source, and this end it could be a drain, and it represent a transistor, right? That is what is being drawn here. So this is nothing but green line, so it is N MOSFET, and this is nothing but yellow line, and poly is in vertical, so it is nothing but it is representing P MOSFET. Suppose if there is an explicitly you are representing a contact here, then it is not NMOS, and this is not PMOS. Rule 4, in a CMOS, a demarcation line is drawn to avoid touching of P diffusion and N diffusion. All PMOS must lie on one side of the line, and all NMOS should lie on the other side. So if you take this, so this is yellow and this is green. So it represents, this side is going to be pull-up network, and this side it is going to be NMOS, and NMOS will be connected to ground and PMOS will be connected to VDD. So this line is called demarcation line, or the line separates NMOS and PMOS. Right, we will take up a slide to understand how to draw inverter. So inverter is, it is going to have a PMOS. Source is being connected to VDD. Drain is connected to the NMOS of the drain, and it is source of the NMOS is connected to ground. This is V in, this is V out. So as usual, we will first draw power rails, which is nothing but VDD and ground. So to represent that, we have to take blue line. So this is VDD, and this line is nothing but ground. And then we have to draw the PMOS. So for PMOS you need P diffusion. So P diffusion, we will take up this. We will take up this. For N diffusion, we want green color. So green color. The source of this PMOS should be connected to VDD. So you want metal line. So metal is going to be represented with this. So this is my source. So we want gate now. So to show the contact, you should we have to make a connection which has been connected to ground. So this source should be grounded. So we consider this as the source. Then we have to draw this polysilicon, right? So this polysilicon is going to represent gate. So we have followed all the rules. Yes. So for drawing this contacts, we have to use what is called as black color. So this is black, and this is also black. Right, this is going to represent my source, this is going to represent my drain, this is going to again represent what to say, we need, okay, this could be taken as source and this could be taken as drain of N MOSFET. We have to change the, we want eraser now, so erase this. Connect this. So both the drains have been connected here. So take a metal line. So this is my Y, and this is my A. So this part is going to represent my PMOS, and this part is going to represent my NMOS, and we can draw a demarcation line. So this line is called demarcation line. So the X represent the metal contact. So this is how we have to draw the stick diagram, and this example is nothing but 3 input NAND gate. So we know how to draw NAND gate. In the last video we have seen how to draw NAND gate. So PMOS will be present in parallel with A, B and C. A, B and C. This is ground, this is VDD. So bottom we have a green line, so it says it is P diffusion, and you are going to stack 3 NMOSs in series. We are going to stack 3 NMOS in series. In the top we have ABC, all are present in parallel. So this end is going to act as my source of this. S is representing source, and the source is being connected to VDD. If you take B, if you take this connection B, this is nothing but it is going to be share this B and C is going to share the source node or source diffusion. So we don't explicitly draw two sources. So instead of that, this single X is going to have two sources, and if you draw a line, this polyline, then it says that there is a transistor. This polyline says here we have a transistor of NMOS type, and here we have a transistor of NMOS type. This is how you have to understand this layout stick diagram. Next we will see about layout diagram in the next video lecture. Thank you all.